All right. Hopefully 3-3 went well for everyone. 3-4 is going to be very similar to that, but we're going to be looking at multiplication and division for solving. So those are our learning targets. Use the division property of equality and multiplication property of equality to solve the equation. All right. Just like the addition and subtraction properties of equality, multiplication and division is just saying when you divide each side of an equation by the same non-zero number, the two sides remain equal. Okay, that one you have to add in the premise of non-zero because it's undefined to divide by zero. So if you check in your calculator, if you take 15 divided by zero, you'll get an error, right? And it usually says like divide by zero error or something like that. It's because it's undefined. So with division property of equality, we have to have that disclaimer that you can divide both sides by any number as long as it's not zero, and it has to be the same on both sides and it'll stay equal. With multiplication, you can multiply both sides by the same number and it will remain equal, including zero. Okay, multiplying, you can multiply by zero. All right, using multiplication or division as the operation, set up as many equations as you can with the numbers 5, 4, and 20 only once in each equation. So why don't you use multiplication, division, and set up as many equations as you can using those three numbers. And I'm going to pause here. Think of as many as you can. All right, so let's list them, right? So we know that 5 times 4 equals 20. We know 4 times 5 equals 20. 20 divided by 4 equals 5. Whoa. A little crazy there. Let me back that up. Equals 5. And 20 divided by 5 equals 4. So those are the equations that we can write using multiplication and division to relate these numbers. And so what we're going to be doing is we're going to be solving for an unknown. For example, right, I would say 5x equals 20. So 5 times something equals 20. And we should know that it's 4, all right? But what we're going to be doing today is we're going to be using inverse. So if this is a multiplication, we know that division is the inverse or the undoer of multiplication. So if I want to undo multiplication, I'm going to divide both sides by 5, right? And 5 divided by 5, right, we say that it cancels, but really 5 divided by 5 is equal to 1. Okay, and remember, we know that there's a 1 right here, but we don't write that as the coefficient. We know that x, right, is equal to 1x, or saying the same thing as 1x. And then here, 20 divided by 5 equals 4, right? So that's how all of these numbers are related to each other. But we can solve for a missing value by using inverse operations, right? So to solve for this, right, notice that it is connected here with division, right? And then these middle two, right? If I want to solve for this, okay, divide both sides by 4, and we're left with 5 by itself. Okay, so that's the connection between multiplication and division. The same can be said for addition and subtraction. All right, so it says solve using division. All right, remember, division and multiplications are inverses of each other, meaning that they undo that operation. So again, when we solve, let's get into the habit of making a left side of an equation and the right side. And so here, if I were to read this, 9 times some number equals 18. All right, and hopefully we're good with our basic skills, multiplication of integers. And I know that my answer is going to be 2, but the process to solve, because it's not always going to be integers, right? Maybe it's 3.5x equals 271, right? And I don't want to have to just keep plugging in numbers till I get there. So we're going to use inverse operation. But if you ID that right away, you can write x equals 2. That's fine. And hopefully you understand the problem, be able to do that. But to solve, we divide both sides by 9, right? Because 9 divided by 9 is 1x, and 18 divided by 9 equals 2. Okay, again, we can always check this out, right? Does 9 times 2 equal 18? Yep, so that's my solution. 5 times what equals negative 50? Okay, again, I gave you the sheet with the rules for integers with multiplication and division. But I should know that in order to multiply and get a negative number, one of my values needs to be negative. So going into this problem, I should know that y is going to equal negative something because I need to multiply a positive 5 by something to get negative 50. Right? And hopefully we all know what it is, but if we want to solve, right? Sorry, I didn't make my sides here. I divide both sides by 5. Okay, so that would give me 1y. And negative 50 divided by positive 5 is going to be negative 10, right? Because negative divided by positive is a negative, right? Again, if I plug that in, 5 times negative 10, does it equal negative 50? Yep. All right, so go through and see if you can solve 3 through 8. All right, solve 3 through 8. All right, let's see how you did here. Okay, so in number 3, should have gotten h equals 3, right? And if you plug that in, 20 times 3 equals 60. Yep, that one checks out. Okay, number 4, the variable was on the right side. All right, and some of you may want to write that as 5b equals negative 30, just to always have your variable over there, but it doesn't matter. Divide both sides by 5, you should get negative 6. Right, and remember, answer keys will probably put the variable first, right? These two are saying the exact same thing, right? To check that out, 5 times a negative 6 will give me negative 30. Here, 24 divided by negative 2 is negative 12, right? Check it out. Negative 2 times negative 12 is a positive 24. Remember, negative times a negative is a positive. Right? 4 times 4 would give me 16, so that's a good solution here. Here we have negative 10 times 8 would give me negative 80, so that checks out. Oop, missed that there. Right, but remember, here's how your answer key would most likely have that written. Here we divide both sides by 2, right? 0 divided by 2 is 0. Check it out. 2 times 0 equals 0. Okay, notice we talked at the beginning that you can't divide by 0. Okay, you can divide 0 by a number and it's going to be 0. But notice here I divided by 2. So I didn't divide by 0. So that's not one of those undefined ones. 0 couldn't be in the bottom there. All right, using multiplication to solve. So here we have a division problem, right? Meaning I have some number divided by 12 equals 2. So I'm trying to figure out what that number is. When you divide it by 12, it's equal to 2. And hopefully we have an idea here. But I want to inverse or undo this divide by 12 by multiplying both sides by 12, right? Because 12 over 12 here would equal 1. Okay, so I'm left with just 1k, and that's my goal in solving, is to isolate the single variable term. And I have over here 2 times 12, which is 24, right? And again, I could check that out. I know that 24 divided by 12 is 2, so that is a good solution there. All right. Number 2, right? This is divide by negative 9. So I'm going to multiply both sides by a negative 9, right? So notice that this was a negative. I have to multiply by the negative, and that would equal 1. So I'm left with E, right? Isolating the variable. And then I have a negative 6 times a negative 9. That'll give me positive 54. So E should equal positive 54. And if we check, 54 divided by negative 9 equals negative 6. All right. Go through and see if you can solve 3 through 8. All right, pause the video here, see if you can solve 3 through 8. All right, let's see how you did here. So for number 3, we should get negative 60, right? Because a negative divided by a positive is a negative. So that checks out here. Negative 72 divided by positive 9 is negative 8. I get some bigger values here, right? And listen, basic skills wise, I should be able to longhand multiply 4 times 19, but really the goal here is to be able to figure out how to solve these, right? Knowing that I need to multiply both sides by 19. So just double check with your calculator, right? And we get 76 right here, timesing both sides by negative 8, right? Notice that negative times negative ends up being a positive 120. So be careful with your signs. Right here, 20 divided by 4 is 5. Right, and again, if we were to solve that out, we'd multiply both sides by 4. Right, that leaves me with 1g. 4 times 5 is 20. Right, and number 8 here is negative 42. Right, and again, a negative divided by a positive, that's how we get a negative. Right, so in multiplication and division, if I get a negative, one of the values has to be a negative. If I get a positive, either both values are positive or both values are negative, right? So look here, negative times negative equals a positive, right? And then the problems where I had one negative, right here, negative 42 divided by 6, that would equal negative 7. Okay, so be careful on your signs. Use those rules, integer rules, to help on those if needed. All right. Costs $3 per car to use hiking trails, to use the hiking trails parking lot along the Columbia River. If the income from the hiking trails totaled $12.75 for a single day, how many cars entered the park? Okay, I want you to take a minute, see if you can set up this problem and then solve. All right, so let's look at this setup, right? It says it costs $3 per car, right? So for one car, it's $3. For two cars, it's $6. For three cars, it's $9, right? 4 and 12. So you can see that we're just taking $3 and multiplying it by the number of cars to get a total, right? And then if we keep reading, it doesn't matter where they're parking, right? It just tells us they're along hiking trails, Columbia River, totaled, right? That's where my equal sign comes in. So they totaled for these cars $12.75 for a single day, right? So I mean, I could guess. I could say, all right, well, if they had 100 cars, how much would I make, right? Well, that'd be $300. Right? That's not quite 1,200, right? So you could keep guessing. Or you can say that this is 3 times the number of cars. So if I wanted to inverse this multiplication problem, I would divide both sides by 3. So here, right, 3 over 3 is 1c, right? We don't have to write the 1. So we end up with the number of cars, right, because that's what c is representing here. The number of cars would be 425 cars, okay, not dollars, right? The dollars canceled out there. This is number of cars, 425 cars parked there for the day. All right, your practice for section 3.4 starts on page 117. Do the following problems on a separate sheet. Okay, make sure you're checking your answers as you go along. All right, if you have any questions, shoot me an email. Hope everyone has a great day. We'll talk to you soon.